Hi guys. There is a video going over this on flipped math, but I wanted to also go through it myself. So if you still don't understand, you could watch that video as well. So remember, implicit relationships were when x's and y's were mixed up. Well, they follow the same rules as functions. If the derivative is 0 or the derivative does not exist at a point, then that point is a critical point. If the second derivative is greater than 0 at that point, then the graph is concave up. So all of our increasing, decreasing, all those rules stay the same. It's just we have to have an x and a y to be able to find out our information. So we have this curve, and we want to figure out at this point, is the curve increasing or decreasing? So increasing or decreasing means we need to have the first derivative. So when I take the derivative and it has an x involved, that would give me 9x squared. Now technically there'd be a dx, but I don't need to write that. Derivative of 3 is 0, equals, now this is a natural log, so we would do 1 over what's inside the parentheses times the peanut. And the peanut would be 8y dy dx. All right, so I'm going to do a little simplifying. We could simplify that right side a little bit because 4 goes into 8 and leaves me 2. So I had 2 over y dy dx. And to get dy dx by itself, I would multiply both sides by the reciprocal of 2 over y, so y over 2, and that would cancel out, make it a 1 over here, so I would not have that anymore. So I have 9x squared y over 2 equals dy dx. Dx has an x and a y in it, so I need to plug in both to figure out whether we're increasing or decreasing. So dy dx at that point, and sometimes if you want to kind of make sure people know that you're evaluating it at that point, some people use a notation where they kind of draw a line and put -1 1/2. So I'm telling people that I'm plugging in -1 1/2. Or you could just say you're finding the derivative at that point, and I'm just going to plug in those. So 9 times -1 squared times 1/2 over 2 would be the same as having, so that would make that positive. That'd be the same as 9 over 4, which is positive. So dy dx is 9 over 4, which is greater than 0. So we are increasing at -1 1/2. I should say the curve is increasing at that point because dy dx is greater than 0. The next one's asking about concavity. So concavity means I need the second derivative. So let's start with taking the first. So I'd have 2x. The derivative of -3 is nothing. The derivative of ey would be e to the y times the derivative of y, which is dy dx. Now, to take the second derivative, I would need to solve for dy dx, which would mean I divide by e to the y. So I'd have dy dx equals 2x over e to the y. And I want to take the derivative again. So I'm going to take the derivative again. And this is the notation we use for the second derivative. We're taking the derivative twice with respect to x twice. So this is a quotient. So the derivative of the top is 2 times the denominator minus the derivative of the denominator times the numerator, all over the denominator squared. Now, you could try to simplify this a little bit, but you don't have to. You could just plug in negative 2, 0 straight into here. So d squared y over dx squared at this point would be 2 e to the 0 minus e to the 0 dy dx. So I need to plug in that point into there as well. So I'd have 2 times negative 2 over e to the 0 times 2x all over e to the y squared. Now, e to the 0 is just 1, so that's giving me 2 minus, that's a 1, that's a 1, so I'd have negative 4 times negative 4, so that's 16 over 1 squared, which is going to be negative. So I would say at negative 2, 0, the curve is concave down because the second derivative is less than 0. Next one. They give us this, and they say it's known that dy dx is this, and the second derivative is that. So you will see sometimes on a free response that they actually give you what dy dx is, and sometimes they'll ask you to prove it. Nice that they would actually give you what you're trying to get to. It's not asking me to do that on this problem, so I'm going to go ahead and solve the problem, and then let's come off to the side and just kind of prove where that came from. So to figure out if it's a relative max or relative min or neither, first I would plug in that point into dy dx. We need to know if this is going to be a critical value. So at 0, 1, if I plug into the equation for dy dx, I'd have 2 times 0 over 3 times 1 squared minus 1, and that equals 0. So this is a critical value. It's a possible max or min. Now, since they've given me my second derivative, which was very nice of them, I can plug that point into there and see if I'm positive or negative, if I'm concave up or concave down. All right, so the first one, that'd be 2 over 3 minus 1, 2 over 2, that'd be a 1. Now the numerator would be 0 because 0 times anything would be 0. So that's just 0 divided by 2 squared divided by 4. So I just get a 1. So the second derivative is greater than 0. So I know it's a critical value, the derivative is 0, and the second derivative is greater than 0. So that is concave up. So concave up means that 0, 1 is a relative minimum because, and I'm going to say two things here, because dy dx equals 0 and the second derivative is greater than 0. So I'm going to include both of those in my explanation. Now I said I was going to come off to the side and kind of prove the dy dx. So you'll see that kind of question asked a lot where they give you the curve and they give you dy dx and they want you to show it. So let's come off to the side and just practice that. If I took the derivative, I'd have 3y squared dy dx minus 1 dy dx equals 2x. Well, notice that both of those terms have a dy dx. I can factor out dy dx, and I'd have 3y squared minus 1 equals 2x. This is just a number. Remember when we plugged in, it's just a number. So to solve for dy dx, I would just divide each side by that parentheses. And I got that. Now I invite you, if you want to challenge yourself, to take the derivative of this and see if you can make it look like that. So pause the video and try it. Dy dx was 2x over 3y squared minus 1. So if I take the second derivative, I'd have 2 times 3y squared minus 1 minus, let's see, that'd be 6y dy dx times 2x divided by 3y squared minus 1. Okay, so we're trying to make it match. Oops, squared. So I noticed that they had two fractions. So if I separate this out, since they're both being divided by 3y squared minus 1 squared, I can separate it into two pieces. And I would get, let's see, 12xy. But it didn't have dy dx written there. It had 2x over 3y squared minus 1 over 3y squared minus 1. Squared. So this would cancel and give me 2 over 3y squared minus 1. And this would give me 24x squared y over, whoops, it's supposed to be a minus, 3y squared minus 1 cubed. I think they made a little mistake in there. I think that should have been cubed. But would it have made a difference on our sign? No, it wouldn't have, but that's kind of interesting. So there's a homework sheet for this. I should be back tomorrow. See you then.